Thank you. So happy to be here. Such a long flight. You know, it goes up, then it comes down, and you are in the same time when you left. So the easiest trip ever. So today we talk about agentic AI and the future of AI. My name is Heli, and the picture here is, of course, made by AI. Do you know why I know it? She already gave you the clue. We are the happiest people in this whole planet. And that person doesn't look very happy. She looks angry. So it must be AI, since we are always happy. So I have graduated from University of Helsinki with master's degree and currently working on my PhD and hopefully done by the end of this year. But if next year I come here and I say, I'm still working on my PhD, please say boo, okay? Thank you. I have been working with Oracle products for many years. Therefore, usually the demos we do, we use Oracle database at some stage because that's my favorite database. I've been on IT since 90, if I'm very honest, since 80-something, but I don't want to tell that because I sound very old. So 90 is a good word here. So anything to do with data and databases is close to my heart. So that's kind of why I'm here now, because everything with AI, ML, and so on is about data. I'm a CEO for Merkle Finland, a consulting company in Finland, soon also in Singapore. He will be moving to Singapore to run the company. I'm an Oracle ACE director, which is the highest level on this award program, public speaker and author. So you all also know that we are very happy, but we are very quiet. We never speak. We are the exceptions. We do speak. So I actually go to many events every year, and Matias is joining me many of those. I have written 4 books so far about database designing, about SQL, PL/SQL, and then about machine learning. And hopefully writing more books, but my husband told me not to write anything before the PhD is done. So you have to wait a little bit for more books to come. But here's Matias.
Yes, so my name is Matias. I'm the CTO for Miracle Finland. Well, who am I? I've been on IT since birth, since I'm the son of Heli, but professionally since 2022. I do OCI, cybersecurity. I like to play with IoT devices. I do machine learning, AI, the list goes on. I like to learn something new every day.
And do you want to tell at least about this picture here on the bottom?
Yeah, that's me in South Korea in a gaming cafe.
Yeah, his dream came true.
Yeah, I always wanted to play in a gaming cafe.
Yeah.
It had a 300 ping, so it wasn't really fun, but yeah. Yeah, for hobbies, I like to learn cool stuff. I like to play with tech devices. I have like 5 Raspberry Pis. So yeah. And also I'm an Oracle ACE Pro. Don't forget about that.
I'm probably the youngest one, I guess.
Yeah.
So we talk about agentic AI, and the first thing people say, agents will take my job. So will they take our jobs? Well, that's what they tell us. You know, companies that have already replaced workers with AI, they will be replaced. Do you want to tell more about this?
Yeah, so Klarna AI Assistant handles 2/3 of customers. Klarna AI is doing the job of 700 workers. The Salesforce CEO says that we don't need human workers. But what about Harvard? Harvard says that AI won't replace humans, but humans with AI will replace AI. And so does Forbes. And the surprising reason why is humanity. I don't know why, but it's a clickbait. But are you worried about these? Is this going to take your job? Or this one? Or this one? Or would you worry about your dishwasher getting filled and emptied without you? Or someone cooking your food? Or a shopping assistant? It can shop what you're missing in a pantry. It knows your size, what you like. It knows the size of your family members. It will shop for you. It knows your budget, how much money you have. It knows what you need. And it can be more important and fun stuff while it shops for you, like going to Sweden to present. But would you miss these jobs? To book yourself a flight and a hotel, making notes in a meeting, to do the to-do list, follow the to-do list, and booking another meetings with your based on the attendees' availabilities, etc., etc. Would you miss these jobs? Or would you miss a job of an assistant? Well, 2025 is the year of AI agent. Is this? Well, NVIDIA says it is. And the Tech Target says it is. So Agentic AI. I'll let you
Yeah,
have the
so let's
stage.
talk about it since it's 2025. So we should talk about agentic AI. So agentic AI refers to artificial intelligence systems that can act autonomously. They can pursue goals, make decisions with minimal human intervention. So we don't have to tell what to do, it knows what to do. It can reason, it can plan, and it can adapt to achieve complex, open-ended objectives. It's goal-directed. It's not just, data-driven or rule-based or something like that. It is goal-driven. So a simple chatbot would be like, answer this question. While as if we have an agentic AI, that would be doing things independently, research, schedule tasks, optimize workflows, and so on and so on. So the questions would be like, plan my week, book a trip, this kind of things. So we are in a very different level with just a chatbot. So that's the difference. Then when we talk about these agentic AIs, the first thing that comes to mind is workflow. That is not really an agentic AI, because a workflow is something that you have predefined. So you have already predefined what will happen next. So that's not really an agentic AI. It's on the way to that direction, but it's not really agentic AI. If we think about workflows, it might be a prompt chaining, routing, parallelization, orchestration workers, evaluation optimizers. For example, if we think about prompt chaining, the task can be divided into subtasks. And it's a trade-off between accuracy and then being able to have those separate tasks driven separately. So for example, if we generate a summary, and then we send this one to another prompt chaining, or to another prompt where we translate it to another language. So first prompt, write me a summary. Second prompt, translate it to Swedish. Or write an outline of the document. Then another model, verify that the outline makes sense. The third one, write me a document based on this outline. So prompts chain together. Or evaluator optimizer. So idea of evaluator optimizer is that we have an LLM. That LLM, by the way, it's a large language model, if you are not familiar with this acronym. So one LLM generates a response, and then another LLM comes and evaluates it, and maybe gives even feedback for that. And that can be happening in a loop. So for example, when we do this kind of things, we need to have evaluation criteria, so it's able to evaluate it. And we also have to have measurable values so that we can know if it's improving or not. If we don't have these, this really doesn't make much sense. For example, translation. So we make a translation. It's a very complex text, a scientific text or whatever. And then we have another LLM that will evaluate how well it did. Maybe give feedback. You should do something more with this and that, explain this terminology better and whatever. Or it could be a complex search task. So we are doing research for science. The first that comes out is not good enough. So the evaluator will say, you have to go and find more research on this topic and write more about this and this thing. Then it writes a better document or research article. The other evaluator goes again and does the research and says, we still need more research, go and find more research, and so on, until the evaluator says, this is good enough, we can go. So the agentic systems rely on augmented large language models that can reason. They have memory, and they are able to use tools. So that's what we are talking about. So why is it possible to build this kind of systems, and why is it possible now? Well, first of all, the rapid progress of reasoning models. So not just LLMs, but reasoning LLMs. And also the ability that we are able to guide this process with natural language. So we don't have to program anything. We just use our natural language, and we guide the process through that. So I think those are the two key features that we are able to build the agentic solutions nowadays. So AI agent uses LLMs dynamically and autonomously. They maintain control over how to accomplish this mission, this goal, and they are independent. So they might ask my advice every now and then, but only if needed, and only if I said you have to ask my opinion before doing anything. Like before buying a trip to somewhere, ask me if I'm okay to pay 5,000 euros for that, okay? So I can tell I have to be asked, but I can also say just do it freely and make sure that everything goes well. There are sometimes some risks. I will show you some risks later today. So when to use or not to use AI agents? Well, KISS principle. Keep it simple, stupid. So if it's not necessary to use AI agents, don't. Only when you really need to use AI agents, then do. So if you can just optimize the prompts and the LLM calls, why not do that? Why would you go to a more complex solution? If complexity is needed, like workflows, you can't define them beforehand well enough, then you might want to go to AI agent solution. When you need flexibility and somehow model-driven decision-making processes, you might need AI agent solution. So how it works is that we have an LLM which has skill of reasoning. Not every LLM does. So LLM with this capability. It has a memory and skill of retrieving knowledge from any kind of data source, and skill of using tools. So that's what the system is about. I'm going to explain this many times in this session, but just from different angles so that everybody gets to the same page. So I just said you need the LLM that can reason. Now there's a question. Apple just announced this paper a couple of days ago, I think, saying that they cannot really think. So the reasoning is fake. They can only remember. I'm not going to take sides on this, but anyway, there are always doubts in everything we do with machine learning, AI, and agentic AI. Always, people questioning things, which I think is good, because we need to be questioning, not just taking everything just like it is. So, as mentioned, we have an LLM which is able to reason. We send a task or goal or job or whatever to our LLM. It goes and queries, gets results. It uses tools, gets responses from them, and it remembers our conversation. And based on that, job done. So that's how it works. By the way, I just wanted to have this cute thing here. He's always complaining to me, you shouldn't use that, that's not an agent. But I kind of think it's an agent.
No, it's a Reddit logo.
Yeah, I know. So the agentic system, you can have just a single agent. So I'm just calling one single agent who's doing my job, and that's it. Or you might have several agents who are able to do their own jobs, just like this. And if you were in the previous session about agentic AI, you probably learned about different kind of possibilities of doing this. So there are different kind of architectures, but I skipped those slides because you probably already know them. So example here. So I want to book a trip to Singapore. This agent knows about my profile and my preferences. It knows my name, date of birth, passport info, and all these kind of things. It knows my preferred of direct flights. I don't want to have many changes. It knows my seating preferences. Aisle, please. And if there's any single seats without anybody sitting next to me, I'm a Finn, come on. I don't want to have neighbors. So it knows that as well. And so many other things about me. I'm a Marriott Bonvoy customer. It knows my number, and it knows I prefer Marriott. It has access to my calendar, so it can see when do I have meetings in Singapore. So it knows I should be there on those days. So it knows kind of my timeline, and it knows my budget preferences. I already told 5,000 is too much for my flight. So it kind of knows what I prefer and what I want. So what will happen? I will say, book me flights and hotel for my trip to Singapore. That's all I tell. Book a flight is the first task here, the first goal. It goes to my flight agent. Here are the flights, is it okay? So it goes and checks those flights that will match my criteria. And asks me, is it okay? Because I said, I don't want you to book anything before asking me first. And I will go and check it, and I say, yes, book. And it books my flights. The next thing is, book me an accommodation. So I could have an agent doing all this, but I want to do it myself now, so I say, book the accommodation. And that will go to my hotel agent. It has booked my it finds perfect match for my requirements, and it says, here it is, shall I book it? I said, yes, please book it. And that's it. Problem solved. I didn't have to do it myself. You know how fun it is to find different options of hotels and flights and everything. And I have preference, like I would like to have a refrigerator in my hotel and this kind of thing. So it can just take care of all those issues. So what about another thing? Matias, I think I will let you explain this.
Sure.
So agentic AI for a car repair.
Yeah. So building an agentic AI for car repair. It's a system that can diagnose your issues, recommend fixes, and potentially execute repair-related actions. It's not going to actually fix your car, but it will suggest like ordering parts and scheduling the service. So the agent will need to perceive inputs. So like what are the symptoms and the diagnostic codes of your car and reasons over the repair options. And act with an enterprise context, a repair shop, for example. So let me play a video because I forgot my laptop. So if we send a message, can you tell me what is wrong with the car that it's not starting and the engine light is on, and give the license plate number, it will suggest that for a class code coolant flush, no, it gives a reason that the engine light is often linked to coolant system issues. Also recommends a battery replacement, tells me it's 4 hours to replace a battery, and an oil change. Well, let's see. That's not a good fix though. Now if we tell, could we do the PC001, which is the oil change, and the battery replacement too. Okay. Now it'll give me a procedure price and estimated duration. Wait until I scroll down on this video, like here. It will say the total duration is 5 hours. The spare part cost is $320. Total procedure cost $200. The estimated total cost is what, $520. It will give me the available schedules of the mechanics. There's Eric, Jari, and Nora, and tell the actions required. I say, okay, could we order 20 of the oil filters? This is like me as the mechanic clerk speaking with my agent, with a customer in front of me. So I see we don't have any oil filters in our garage, so we want to order more. So if we order 20 more, we can just stock the shelves there. So I'm ordering parts for the car repair place 2 here. Okay. Now the order is 20 oil filters. They'll arrive on June 11th. Okay, that's good. Now let's schedule the service for our customer. Let's see, we have Nora is free. So yeah. Let's schedule the service for Nora. And the arrival date is somewhere around June 11th when the oil filters come. Yeah, after the oil filters have come, so June 12th. And yeah, now we have ordered the service, ordered the oil filters. Nora knows exactly what to do, and it's in her calendar now. So that's how we could use the agentic AI thing with the car service too.
And the good thing here is that I don't have to bring my car there, and then they will tell me, oh, yeah, it will take 2 weeks before we get the part that you will need. So you can leave your car here for 2 weeks, which I don't want to do. So now we can just get all the pieces in places without anybody actually doing anything. The machine is doing all the job. But Matias, what's happening behind the scenes?
Well, we can see what the machine is thinking there. So the reasoning. Now if we toggle this, we can see what the computer is actually thinking there. So yeah, now it thinks the car isn't starting, engine light is on, license plate this. It will take the license plate number, the car make, the model, the year, what the kilometers. Yeah, it sees exactly what the car is. It will think what it's going to say. Then it retrieves get diagnosed reports and records of the car. all what is the previous things that it has broken, the service history, everything. It knows exactly your car and what's wrong with it, what has ever been wrong with it. It knows all the history of it. It knows who has ever fixed it. Is it a good mechanic or a bad mechanic? It knows all the error codes there. It knows the procedures. And it will recommend based on what it thinks is actually the best one. So yeah, get verified service requirements. It will see the product codes, the current quantity, what we have in the back. It will estimate the duration, everything behind the scenes, but it will not tell you all this because it will reason the best one for you. So it's like speaking with another person there. So, and this is what you will see. It will calculate them all and suggest you something. And action required, the oil filters, they're insufficient. And there, if you want to order the 20 more, it will suggest you maybe you want to ensure the stock for the future is better than now. And it will now order 20 more. It will make a note that there's going to be 20 more of them, hopefully. And now the order has been confirmed there. It will tell me this. Now if we suggest the service for Nora, it will take all the info, send them to Nora, put them in the calendar, schedule service arguments. Yeah, it's free she is free. The service start time is that. It will put it in Nora's calendar. Yep. And it will tell me this. And it is all okay.
So what Matias was explaining here is a thing called react. So it's reasoning, and based on reasoning, acting. So what should be done next? So how do you build these systems? If you were attending the previous session, you heard about the Microsoft solutions, but there's plenty of solutions. There are different kind of frameworks, and I promise you next week there's 5 more or 10 more, 100 more. So for example, this kind of possibilities, LangChain, AutoGen, Super AGI, Grew AI, a lot of different options. But that's not all. There's still plenty others. These are like more code-based, so you code more. Then there are some that are, that are more like low-code, no-code kind of things. Then there are specific tools for specific use cases, like, for example, a UA, user interface, or this kind of things. So there's different kind of things. The last one is, by the way, Hugging Face. Demo kind of thing, or it depends on the ecosystem. So what kind of ecosystem you want to build. If in our demo, we chose to use LangChain ecosystem. In the previous demo, if you were attending, was the Microsoft stack. Crew AI is very popular, so depending. But the good thing is that you don't have to choose one. You can use many of these depending how you want to build your system. Take the best for best job. So what was used in the demo Matias was showing to you is Python, of course. Then this LangGraph setup. So we had LangChain, LangGraph, and Langsmith. We used MCP. I will explain that a bit later. We used A2A, and we used Oracle Apex for the user interface. That's a low-code tool in the Oracle database. And we used Ollama and Gwen 3.8b as a model. And we wanted to use Ollama because we wanted everything to be like in your environment. That's why we needed to use Ollama. So you could, also, of course, call APIs and whatever for the model, but we wanted to have everything in our environment. So this is how it worked. So we have a user, we had a coordinating agent, we have A2A, we have all the agents, we have MCP servers for different kind of data sources that were used for the job. So MCP is Model Context Protocol. It's kind of an open protocol from Anthropic. It's very popular nowadays, so it just came out and suddenly everybody loved it. And I'm sure there's a good reason for that, because it is really very easy to use, and standards are always good because it makes it easier for a developer. So it standardized how applications provide context to LLM. It's the connections to data sources from your tool. So it's like USB port for AI applications. That's how it's been described, and I think this is a good explanation. So you just have your plug, and you plug it to different places to get different kind of data. And different kind of data, first of all, you have a server, and then you have a client. So the different kind of data could be, okay, I don't go to this, but I go to the last one. Could be a Google Drive, Slack, GitHub, Git, Postgre, Puppeteer, Oracle database, any kind of data source you plug your USB-C to. That's how it works. So that is the protocol between your agent and the data source. The other one people talk about is agent-to-agent protocol, A2A. So this protocol is between an agent and another agent. So it is not a competitor to this one. It actually complements it. So the first one was about an agent and a data source. This one is an agent and another agent. So a very good thing. By the way, excuse me, this is from Google. And despite it comes from one of the big ones, people still loved it, and it's been used quite widely. So when to use these AI agents? If you have an open-ended problem, you don't know how it will go, so you can't determine it beforehand. Or it's a very multi-step process. So you have to do a lot of things before you get to the point. You get the results. Or the process is able to improve over time. So it's able to learn. So based on the feedback it gets, it improves its performance. It gets better. Those might be use cases for AI agents. So as said earlier, it's a system or program that can autonomously perform tasks on behalf of a user or a system. It can design the workflow, and it can utilize tools independently. So that's what we are talking about one more time. There are different kinds of agentic AIs. Since I don't have too much time, I'm just going very quickly. Simple reflex agent is the very simple one. Like a customer service agent, interprets the context of an email and then decides if it's very bad feedback, so people are complaining, sends it to a human being. And if it's something happy customer, it can automatically just reply, thank you for so much for your feedback, we are so happy, and whatever. Or thermostat. So if the temperature goes below something, the thermos will heat up. If it goes too high, it will turn down. So something very simple, that kind of agent. Model-based has to build the model of the world first before it can really work. For example, a travel agent, it will prioritize routes that are the price has changed a lot significantly based on the history. So it has the history data of it. A goal-based agent is actually what I think most of these are, because we can define the goal that has to be defined. It understands the goal and it determines the actions, how to reach this goal. For example, the travel agent has to book a trip for me to Singapore from A to B, and it will define, do we need car, train, flight, how to book it, and so on. And then utility-based is something that it doesn't just define, does it reach the goal or not, but it also defines how good the outcome was, how preferable the outcome was. So it evaluates. For example, travel agent maximizes the utility by weighting the convenience versus the cost. I prefer direct flight, so that's more valuable to me than changing planes. So two options, direct flight or jumping many times and getting to the same place. First of all would be the price, the cost. This is cheaper. But if we use utility-based agent, it will understand for me, the price is like the second thing. The first one is that has to be very easy for me to travel. So it will book me the direct flight. Then we have the learning agents that will learn based on the feedback that they get. For developers, rest in peace, app developers. I end my case here. We can all go home. That's what they say. So, cool. Anthropy CEO says that in the next 3 to 6 months, AI is writing 90% of the code, and in 12 months, we are all gone. Isn't that fun? But AI can be as good as we are. So AI coding assistant refuses to write code, tells user to learn programming instead. Isn't that fun? Because they learn based on the data we have. And this is actually what happens in Stack Overflow. You know, you have been asking questions and people say, go home, stupid, and learn to program. So they do the same. So they are as good as the data we offer to them to learn. Here's another example from Finland. So this is a video a person has taken from a robot. They're very cute, tiny little robots that go from grocery store to your house and bring you the food. That's nice. They work very well. Except this use case is where there's a bridge between two places, and this bridge is something they lift up when the ship comes. So it's lifted up, and there's actually a sign here saying, "Don't go here, stupid. It's closed, and we are going to lift it up." But the poor robot doesn't know it, and do you know what happens? This. Yes. But they were very nice young sailors who went to take it up and brought it back to the grocery store. So he or she is fine, don't worry. But this kind of things happen because they do not know everything. So if we really think they will replace us totally in the future, okay, that might happen, but probably not today. So the benefits of automating workflows, the first simple one is that we will boost productivity because they can just automatically handle boring, time-consuming tasks, and we can do something more fun. They can reduce errors because they are repeating the same things again and again, so maybe some errors are gone. And they are scalable, so they can work 24/7. The only limitation, if they ask me to come and press enter, then I'm going to sleep during the night, so I will be in the morning pressing the enter again. But if they're able to do things without me pressing the enter, they can just work 24/7. What about the AI agents, the next level of these workflows? Improve productivity, of course, because now they can do things without me pressing the enter, and they are just able to do a lot of things. Reduce costs. Well, reduce cost is every now and then. You know, some time ago, it's very hard to tell how long time ago, because in AI world, like a day is a year or something like that. But some time ago, there was a thing called Devin, that is an agent that will program everything and replace us all. And Devin was coming and taking over until they realized Devin is actually very expensive, because Devin is calling the LLM all the time. It's, you know, using resources so much. It came more expensive than a human being. So it's relative to say that they reduce costs. It depends how they have been built. Informed decision making, so they're able to make decisions based on whatever is happening. Not just something I have told yesterday, but if something has changed, they are able to still make decisions. And improved customer experience, because they are able to adapt to different kind of people and different kind of use cases. So these might be the benefits. There are some challenges as well, of course. Data privacy concerns, yes. And that is a really important thing to understand. You cannot send your sensitive data to any kind of AI to do whatever. You have to be very cautious. Ethical challenges. How do you know it's fair? How do you know it's accurate? And so on and so on. Technical complexities. So it requires some knowledge to be able to really implement this. So it's easier to implement a bad agent than a good agent, I would say. And of course, limited computer resources. It takes a lot of resources to train and deploy AI agents. and a lot of integration, integration, integration. We already talked about some of the protocols, but it still requires integration. There are some benchmarks that you can do for agentic AI. So they aim to make these AI agents better. That's why we need benchmarks. Here's a list of some of those from last May, I think. The problems and challenges and trends for these benchmarks are diversity and real-world focus. So how do you keep it in real-world focus when you create a benchmark? Benchmarks are like, they are very fun to create, but how do you know it's benchmarking the right thing? There are limitations, of course. How do you predict what the environment will be, and so on and so on? And issues like overfitting, cost inefficiency, and so on and so on. And it's cost versus accuracy. So which one is more important? So you can't just create one benchmark and measure all the agents with that benchmark and say, this one is the best, because it depends on so many factors. What about the AI agent futures? There's a lot of opportunities in the future. They are able to, I will skip this and I will go to this one. I love this particular, they can personalize your user experience. For example, when you are teaching people, people learn differently. And a human teacher has just limited capability of explaining the thing in different kind of ways. But the computer can do it endlessly. Always find a new way of explaining how to solve X from this equation, for example. So it brings the possibility of teaching everybody individually in the way that suits you the best. So I think this is really good. And it always has the patience, and it's always, encouraging. A human teacher is like, you stupid, you still don't understand it. I've been explaining it for 2 hours and you are still, this is impossible. But the computer is still, happily explaining. I will explain it one more time and so on. So yeah, that's what I like the best. Again, there are problems, especially job displacement and regulatory frameworks. So should we regulate things, or should we let people do a lot of things? And it's a balance between these things. So what is the future in general if you think about AI? I have no idea. So we went to Grok 3 beta. We want to use beta just in case it will be more fun. And I will let you actually explain what it taught us about the future.
Yeah, so the agentic AI will be everywhere. It will not just assist you, it will run the systems. Let's just think about autonomous supply chains, the self-optimizing cities, the personal agent handling everything from taxes to health diagnostics. By 2040, you might have an AI life manager, as ubiquitous as smartphones are now. After the quantum computers come, we have quantum computing, of course. We have the everyday devices will not change much, but the backend systems would, like the data centers, would have quantum computers there. Hyperconnectivity, well, 6G and beyond, not just 6G, like 20G networks, real-life holograms, brain-computer interfaces. Yeah, the IoTs on steroids. Imagine controlling a drone on Mars from Earth with 0 delay. Not like me in South Korea playing with 300 ping. The automated plateau and pivot, the robotics will dominate manufacturing, logistics, but creative and interpersonal jobs. The bottleneck, well, energy cost and human trust. We don't trust the computers, and we like money, so the future with AI robots taking repetitive tasks, the human would shift the meaning drives roles. We would do the artistic things, the innovation and caregiving that the robots can't do. The universal basic income could be standard in wealthier nations because, well, robots do all the hard work that would pay much. The digital lives, we would live in VR or AR. And by 2035, people might live in customizable metaverses for work. We would just live in a VR place in our office that is actually empty. And what would it feel like? Well, oh no, skip that. You might wake up with an AI system briefing your world where you have of your friends who live digitally, drones deliver breakfast, and your job is inventing VR experiences or debugging that AI that doesn't. It would look like this. This is what Grok thinks. That's actually pretty cool. Yeah. So the applications where AI shows up, well, they could manage your schedule, your health finances, minimal input, your smart home things, cities, workplaces, they optimize themselves. The industry, manufacturing will be autonomous. Healthcare could see AI doctors outperforming humans in diagnostic or on surgery. The AI co-author novels, AI would write our books, and what it would look like. Well, AI is indistinguishable from human when it does these things really well. Well, AGI could be a coworker or policymaker. And what's the catch? We'll need to steer it carefully, because otherwise we're going to have like Terminators and stuff. So the human element, well, identity crisis could come, work culture roles and roles, the mental health would degenerate, the upskilling limit, not everyone can transition to high skilling jobs, the rural and urban gaps widen, and conclusions, the world is changing, and how much, how we'll adapt to it, are AI agents the thing for 2025, and what's next? There's so many questions. But what we know is a week in AI is like a year in traditional software. So it will change pretty fast. So we'll see how it changes.
So definitely what we know, the future is exciting, but a little bit scary as well. So we'll see what comes next. Thank you so much for listening. If any questions, happy to answer. But thank you so much.
Thank you.